Colleagues, let's speak about principle 4, which is neural networks. Neural networks in Supervisely is about putting together all fragmented state-of-the-art deep learning technologies or GitHub repositories so that the end users have an easy way to use them via graphical user interface in the day-to-day work. So, neural networks is related to the following column in the task matrix. And let's illustrate it with the following example. Let's consider a part of GitHub where all state-of-the-art computer vision related repositories are kept. That's on the one hand. On the other hand, we have a user with one or more machines with GPU. And then the user might conduct the following thought experiment. Wouldn't it be cool if, and say, if I could run every GitHub repository instantly via web browser? Essentially, it's equivalent to the situation in which each GitHub repository has a run button. And maybe it would be also cool if each GitHub repository has intuitive graphical user interface, which is shown here. And it might be also cool if each repository here is automatically compatible with the data format that users might have. And finally, it would be cool if the user's GPU resources might be utilized whenever necessary for training and inference purposes. But the main point is the following. Essentially, it's what Supervisely is doing. Maybe not for all the repositories, not yet at least, but for most popular ones for sure. So let's go back here and illustrate another layer here, which is Supervisely apps. And Supervisely apps, you can think of them just as forks from popular GitHub repositories, and in many cases there are forks. So there might be other Supervisely components. And the main idea here is that a user might become connected to this universe of GitHub repositories through this proxy layer of Supervisely apps if he just install app engine on or agent on his or her machine. And then once the user becomes connected, he can just click or run an app and have a convenient way to interact to use this app via graphical user interface. So let's speak about this agent or app engine in more detail here. So installation of Supervisely agent on your machine is a critical step, which actually makes it possible for you to stay inside web browser and at the same time your GPU resources, your GPU machine will be utilized as a backend for GPU related computations. So it might sound complicated, but actually from the labeling, from the interface perspective, you just click add button in the cluster page and you see this page where you copy the command, paste it into the terminal, and now your machine is in the running status available. And then you can run apps and specify the machine you would like to use for GPU related computations. Okay, let's move next to the images, to the neural networks in Supervisely in the context of images. So when it comes to images, there are popular tasks like classification, detection, semantic segmentation, instance segmentation, and so on. And there are long-tail tasks like OCR depth estimation and other tasks as well. And when it comes to the most popular tasks, there are really good repositories like, say, YOLO v5, Detectron, MM segmentation, MM detection, and so on. And there are also good repositories for long-tail tasks. But all of these repositories has two common problems. Those are fragmentation and usability bias. And let me address these problems one by one and explain where exactly the difficulties are. So if we talk about, let's talk about fragmentation first, and let's take as an example very good repository MM segmentation from OpenMMLab. The main problem is that the repository either has no connection or weak connection to ecosystem of other CV tools. Like it's hard for repository to support all the data formats or be connected with labeling interfaces and so on. This is the first problem. The second problem is usability bias, and we can illustrate it in the following way. So we can take users with different skills and we can consider three different tasks. Like the first task here is very simple, just take some pre-trained model and apply it on my data. Or say another task, a bit more challenging, to take to train model from the repository on my data. Or the third task is probably the most challenging when the task is to transform the repository in a way that other people within your company has an easier experience in using this repository. And depending on the skill level of the user, these three tasks may be longer or sooner to accomplish. So and those are just estimates here. But the main point here is that the estimates varies from months to minutes, but time estimates should be really different. So for all categories of users, ideally it should take seconds actually to solve all of the tasks outlined here. And let's also say that for less common modalities, or say like video slider, DICOM, or long tail tasks or other types of model, these times estimates will be even worse. So we have two problems. Fragmentation and usability bias. And again, fragmentation is when a repository is isolated from other tools, and usability bias when only high-skilled specialists can leverage a repository. And we also have a process that we explained earlier when we take popular GitHub repositories and convert them into Supervisely apps. And essentially we do two things here. The first thing is we integrate a repository into Supervisely ecosystem. And this integration solves a fragmentation problem. And the second thing that we do, we add graphical user interface that addresses usability bias problem. So let's speak briefly about other modalities, video, sliders, and DICOMs. And the point here is that video, slider, and DICOM are more complex data structures compared to images. And it's even hard in this case to train models, visualize predictions, run experiments, and do other manipulations with the models. And as a consequence of that, the problem of fragmentation and usability bias are even more severe. But the point is that solutions are the same. So if we integrate and add graphic user interface, we will overcome this fragmentation and usability bias problems. The way we solve them. Now let's see how working with neural networks in Supervisely looks from a user perspective. And for that, I will need to introduce the following framework. And you are familiar with this framework from the introduction. So there is Supervisely core components here, app engine or agent, and apps on top. As a reminder, apps are just special types of GitHub repositories. I will cluster the apps in a bit different way right now. So there are training apps, there are serving apps, and probably by the name of the app you may see that for each repository, popular GitHub repository, say segmentation, we have training app and corresponding serving app. Also, we have various inference apps, and the idea here is that, say, I may deploy a model, I may serve an app to deploy a model, and then this model might be used in various inference apps. We will see that later. We will see the examples of this principle later. And finally, there are some other complementary apps that might be useful in the workflow when we do training or inference procedures. So let's move to the concrete example.